about, this is chapter 4, lesson 3, multiplying and dividing monomials. When you guys first look at that, it's like, oh my gosh, how do I pronounce that? This must be something that's really kind of hard. It's really, when we figure it out, it's not going to be as difficult as you think. For a real world link, it says, did you know that football is the most watched sport on American television? What day do we watch the most? Sunday. The playing field in football is 120 yards long and 53 1/3 yards wide. Recently, a local high school cleared an area that measured 2 to the 7th yards long and 2 to the 6th yards wide to make room for a new football field. To find the area, how do you find the area of the football field? How do you find it? Length times width. So I would do 120 times 53 1/3, right? For the playing field, right? But then for the high school, you're going to take 2 to the 7th times 2 to the 6th. Okay, are you guys with me on this? Okay. When we do it though, it's really easy. I'm not going to do 2 to the 7th and do 2 times 2 times 2 times 2 times 2 and then 2 to the 6th. What you're going to do when multiplying, it was 2 to the 7th, 2 to the 6th, right? What it's called, it says multiplying powers with the same base by adding their exponents. The base has to be the same in order to do this. If the base is not the same, you cannot do it, whether it's multiplying or dividing. Okay? All you do is you add your exponent. So what's 7 plus 6? So then it would be 2 to the 13th. That's multiplying a monomial. That's it. Same base. All you do is add the exponent. So for example, 10 to the 1st times 10 to the 3rd would be like 10 times 10 times 10 times 10, which is 10 to the 4th. We're not even asking you to solve the 10 to the 4th. Okay? This is as far as you have to get it. Does that make sense? For right now, anyway. So monomial is a number, a variable, or a product of numbers and or variables. So I can have 80x and 8x because that's multiplying. It is not x plus 5 because that's not a product. Product means to multiply. Do you guys understand that? And it's not x squared minus y squared because it can only happen with multiplying and dividing. It cannot ever happen with adding and subtracting. Okay? Know that. It's only multiplying and dividing. So for example, 1, we have 4 to the 3rd times 4 to the 5th. I'm multiplying, so I can just add my what? What am I going to add? The base is the same, so what am I adding? The exponents. So what's 3 plus 5?
8.
So it would be 4 to the 8th. That's it. That's all we're doing. When you add integers, we also have negative numbers. If I don't have an exponent here, what do I assume that exponent is? 1. So it would be 6 to the 1st power times 6 to the negative 4th. Again, I'm saying we're multiplying, so we're adding the two numbers. So it would be 1 plus 8 negative 4. Don't forget about adding integers. So if I have a negative 4 and a 1, what does that really become? So that equals a negative 3, so it would be 6 to the negative 3rd. But then, as we learned in that last lesson, it would be written as 1 over 6 to the 3rd. Do you guys understand that? Okay, do you guys see why we did negative exponent lesson before we came and did this one?
Yeah.
Doesn't that make sense? Like, why would we teach that before this? That's why I moved around the lesson. Okay? And then they might ask us to solve this, which you guys can solve that. What's 6 to the 3rd? Well, that's 6 times 6 times 6, right? You figure what that is, and you put it over there. So if I have 5 squared times 5 to the 3rd, or 5 cubed, you guys can probably tell me the answer. What would it be? 5 to the what? 5th power. Do I have to solve it? Nope. 12 to the 3rd times 12 to the negative 2nd. Be careful with those negatives. So it would really be 12 to the first, which is just 12, and I'm done. Any questions so far? Be careful with the negatives, that's all you have to do. I'm multiplying, so I'm adding them. Here we have it again, but we just have letters, variables. Do we do the same thing? Yes, we do. But your base is going to be b. So 2 plus 2 is 4, so it would be b to the 4th. T to the negative 5th times t to the 3rd. I'm adding the negative and positive, so it's going to be t to the negative 2nd, which is really 1 over t squared. Don't forget that. Don't leave it as a negative exponent. Always change it to a positive exponent. On your whiteboards, let's do 2a and 2b. We can get 2 on your whiteboards at once. 2a and 2b. If you can do 2a in your head, just write down the answer. Bless you. So 2a, y to the 9th, that's it. 2b would be r to the 1st, which is just r, because I have a positive and a negative. Hold up your boards if you get them both right. Okay, go on to 2c and 2d. Do them into your head if you can. And 2c would be a to the 13, and this would be x to the negative 4th, but then I need to rewrite it because I have to have a positive exponent, so it would be 1 over x to the 4th. How many of you made sure you got 1 over x to the 4th? Hold up your board. How many of you left it at x to the negative 4th? I told you that that's where it would be tricky, right? Don't forget to make it a positive exponent. We don't want to leave anything negative. All right, let's look at our next set of examples. Here we're going to put some numbers in front of our base. So I want to show you off to the side because they always show it over here, but sometimes I'm going to show you what I want for your work. I want 2x to the 3rd times 8x to the 4th. You are still going to multiply 2 and the 8. So 2 times 8 is 16. Then when we multiply x to the 3rd times x to the 4th, you don't have to write that. But what would that be? That would be x to the 7th. I need to see you underlining things or bringing your arrows to it. Do you guys understand that? I don't need to show that I'm adding those. I can do that in my head because it's multiplying and I'm adding. For b, I have a negative 3 n to the negative 9th times 2 n to the 8th. I'm going to underline my whole numbers because I'm going to bring those down together. So negative 3 times 2 is what? Negative 6. Then if I have a negative 9 and a positive 8, that becomes a what? Negative 1. But I cannot leave it. Okay, this is where I cannot leave this part right here. This is where it needs to change. Your whole number 6 is still going to be on the top. Because I'm changing n to the negative 1 is really 1 over n, correct? So that's like saying a negative 6 times 1 over n. And negative 6 times 1 is a negative 6 over n, because it's like 6 is over 1. Do you guys understand how I got that? Sometimes this gets a little bit confusing. Do you see how you're taking the 6 and I'm making that a fraction, and you're just multiplying your two fractions? Does that make sense? A little bit? Okay, let's try 3a. All right, if I have a 5, I have to do the 5 times what? -3. So 5 times the -3 is a -15, and then I have a, and then 2 plus 4 is, so it'd be -15a to the 6th. Raise your boards if you got it. Excellent. Go on to 3b. I see some of us are forgetting some things. And some of us didn't write out all the work. You need to first write the original problem, correct? Yeah. Okay. So then that would be 6 times 2 is 12, and this would be b to the -2nd. A lot of you wanted to leave that, but you can't. You're going to have that's 12. b to the -2nd is like saying 1 over b squared. Are you guys with me on that? So then it would be 12 over 1 times 1 over b squared, which 12 times 1 is 12. 1 times b squared is just b squared. So your answer should be 12 over b squared. Raise your boards if you got 12 over b squared. Excellent. Let's go on to 3c. I do 6 times a -3, which is a negative 18, and then 3 plus 5 is, so it'd be negative 18 times x to the 8th, and I have a positive exponent. 3D, go ahead and do 3D. I'm seeing people writing down the original problem or bringing down lines to show how we're solving the problem. It's simple to show our work this way. So I see the original problem written on your boards, and then I see a line and a line, because 10 times 5 is 50, and then 7 plus 2 is, so you should just have 50 times n to the 9th. Raise your boards if you get that, 50 times n to the 9th. Do you see how I'm circling my exponents? Because I know what I'm going to do with those. Lines underneath my whole numbers. Now we're going to move on to division. It's the same thing, except instead of adding my exponents, I'm going to subtract them. So multiplying, you add your exponents. Dividing, you subtract them. That's it. Follow the rules of integers. Okay? So it says, you can use repeated multiplication of exponents to demonstrate the quotient of powers property. So I have 4 to the 5th divided by 4 squared. That would be 4 times 4 times 4 times 4 times 4 over 4 times 4, and you're crossing them off. So it'd really be how many 4s are left? 1, 2, 3. So it'd be 4 to the 3rd. So all I do is I take 5 minus 2 is 3. So it'd be 4 to the 3rd power. So 8 to the 5th divided by 8 to the 3rd is just 5 minus 3 would be, so this answer would be 8 squared. Okay, are you guys with me on that? We, c to the 7th divided by c squared would just be 7 minus 2, which would be 5, so it would be c to the 5th. Still with me? All we're doing is subtracting, but now you also can have negatives. So if I have 2 to the negative 2nd divided by 2 squared, it's a negative 2 minus 2. The rule of integers, you keep, change, so I'm really just adding 2 negatives. So a negative 2 plus a negative 2 would be a negative 4. So it'd be 2 to the negative 4th, but I don't want to leave it as a negative exponent. So it'd be 1 over 2 to the 4th. Do you see how I got that? I got another example. I have d to the 5th divided by d to the negative 2nd. So it'd be 5 minus 8 negative 2. Rule of integers. Keep, change. So 5 plus 2 would be 7. So it'd just be d to the 7th power. You guys understand that? Okay, let's do 4a. If you can do it in your head, just write down the answer. What's your answer? 3 to the 7th. What would be your answer for 4b?
B to the 1.
B to the 1st, and then just write it as b. Okay, show some work, because whenever you get into the negative numbers, you better show some work. So go ahead and do 4c. So if I'm subtracting these two, I wrote my original problem, and then I say it's 5 minus a negative 2. And I know it's keep, change. So 5 plus 2 is 7, so my answer is 4 to the 7th. Raise your boards if you got 4 to the 7th. 4b.